Got to give the people, what they want. And the people want to get this done. I got to do it quick now because I just got interrupted and I had to start all over. Boom. So I'm going to ask you, please actually listen. Graph of a log function. To graph a log function, you should translate the function into a regular equation, an exponential equation. Then make a table of values. Make sure that you look for the positive and negative values of, actually that says x, and it's not really going to be x. It should say positive and negative values of y. Boom. Okay? So, this is why I might say values of y, because a log function generally looks like this. Well, notice if you're looking at that, there aren't any negative values of x. The action doesn't happen over here. It's all over here. Y's can be positive up here, y's can be negative down here. But it's not going to generally, without transformations, have negative values of x. You didn't need to draw all that. Hopefully you just kept it like that. But that's what a general log function graph looks like. So let's just move on to it. Example, you're going to graph f of x equals the log base 10x. So here's what we're going to do. Man, this is going to be quick. I think we got this. We're going to first take this and translate it. So instead of f of x, we're going to say y equals the log base 10x. And you might even be more comfortable if you say log base 10x equals y. Same thing, this might feel more comfortable. Then when you have that, that means my base is 10, my exponent is y equals x. Now we've just translated it into an exponential. Now, from here that I have 10y equals x, I can create a table of values. Boom, 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 x and y. But I'm going to do one thing that's a little different here. Notice that x is actually like an output in this exponential. So I'm going to start with the inputs of y, and I'm going to start them in the middle. I'm going to start off by saying, well, what if y is 0? So 10 to the 0 power, what does that equal? That equals 1. So when x is 1, y is 0, because really, y being 0 made x equal 1. Then I'm going to do the same thing. Well, what if y was 1? 10 to the 1 equals 10. So when y was 1, x ended up being 10. I'm going to do one more. What if y was 2? So 10 squared equals 100. So when y was equal to 2, x ended up being 100. Now notice, remember, if we go back, I said, remember to look for the positive and negative values of y. I only have positive values of y. So I'm going to move down to negative. Well, what if I have y is negative 1? 10 to the negative 1 is 1/10. What if y was negative 2? 10 to the negative 2 equals 100. And 10 to the negative 3 equals, let's make this bigger, 1/1000. Okay? That's all you need to graph. So now, let's take a look at this. Notice my x values go from 1/1000, which is super duper close to 0, all the way to 100. But most of my energy is happening between basically 0 up here, right? X is base almost 0 up here to x is 10. but really 1, but we'll say to 10, right? So my x values need to go kind of from 0 to 10. My y values need to go from, let's see, from -3 to about 2. So I want to set up my graph accordingly. So here's how I set it up. Notice, nothing's happening. Here's my y-axis, here's my x-axis, this is 0. And we said y needs to go from what? -3 to 2. So those are easy. I can go 1, 2, 3, and -1, -2, -3. See how this is now matching my table. All my love for x is happening between 0 and 10. So if this is 0, I'm going to maybe say, if I'm going to go to 10, I'm going to maybe make, this is 1, we'll call this 1. And notice I'm doing 3 spots. 1, 2, 3, 2, 3, 2, 1, 2, 3, 3, 3, 1, 2, 3, 4, 5, 6, 7. Okay. All right. So let's see. That actually might not have been that helpful because that didn't get me to 10. I don't want to do 2, but I'm going to do it. You all hate me, but it's okay. I'm going to do every 2 so we can get to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Perfect. Now all you got to do is plot your points. Let's see. So my first point is x is -1, x is 1 over 1,000, y is -3. 1 over 1,000 is also almost 0, and y is -3. So it's like right here. The next one says x is 1 over 100, which is almost 0. Y is -2, which is like right here. The next one says x is 1/10, which is still really close to 0. And y is -1. So that's like right here, right? All this is bunched up. But then the next one says x is 1 and y is 0, which is here. And then the last one says x is 10 and y is 1. So this one does this. It's growing, and now it is really going. It's going to keep going. The next spot would be when x was 100, y would be 2. But we're not going to fit that on this graph. Okay, I just graphed a log equation. We're going to do this in class, but hopefully if you listen to this when we do it in class, it'll go a lot faster than if I was explaining it from scratch. Mr. Bass, I'm out. Deuces.